So this may be a tricky differential equation, but it's not. It's simply separable, I believe, and you could solve for the function of y. So we have to go back to algebra and remember what we have to do to get this in terms of x's and in terms of y's, so we could actually separate them. So if you remember grouping, I guess it would be called, or factoring, really. That's what it comes down to. Factoring, so that we can get 1 minus x squared plus 1 minus x squared times some y. Okay, so what I'm saying is that I'm gonna do this. I'm gonna do that so it's easier to see. Now that you have this stuff, I'm gonna factor out a y squared out of this parentheses. So I'm gonna rewrite this as x squared y prime minus or equals 1 minus x squared plus y squared times 1 minus x squared. See that? Now I'm gonna do that. Now I'm gonna put this as well. It's kind of, I like to put parentheses just to see what I'm factoring out of and so forth. So if you notice here, I could factor out a 1 minus x squared out of this whole equation. So what we can do is write it as this, x squared y prime. So I'm going to do 1 minus x squared, the brackets. So if you factor out 1 minus x squared here, that's just 1, plus a y squared, like that. So now it's separable. So first step of writing a separable differential equation, you do x squared dy dx. I'm going to just use parentheses now. And now I'm going to separate them pretty easily. So I'm going to divide by this x squared, move this dx over here, and divide by this 1 plus y squared and put it over here. So we have 1 plus y squared divided by, or dy divided by 1 plus y squared. And I'm gonna divide by this exponent, or x squared. So it's gonna be 1 minus x squared over x squared dx. And before I write the integral, I'm gonna simplify this in a way that makes the integral easy to solve. So we're gonna do dy over 1 plus y squared. Now, since it's a singular term in the denominator, we could separate the denominator with its with each numerator term. Okay, so what I'm saying is that I could rewrite this equation such that you have 1 over x squared minus 1 dx. Now that we have that, we're going to move it up here, and we're going to do the integral of this and the integral of this. So the integral of this is going to be simply, if you remember your trig identity or your integral trig identity, I don't know what it would be called exactly, but it'll be the inverse of tangent y, which equals, we got to take the integral of this. So this is simply, okay, I'm going to rewrite it one more time so it's easier to see. It's x to the negative squared minus 1 dx. Now we're going to do our simple rules of integration. Add 1 to the exponent, that's negative 1, divide by the new exponent, that's negative 1. So we could rewrite that as negative 1 over x. This is just a constant, so you just put an x plus c, and you have this inverse tangent over here. So to get rid of the inverse tangent, we simply just do tangent on this side, so we get y as a function of x, you get tangent negative 1 over x minus x plus c, and that is your general formula.